Okay, so let's try one more problem here. So let me share my whiteboard. And let's suppose that here we're given this polynomial of degree 7. And because the degree is 7, right, the degree is 7, we know that there will be 7 roots. And the situation here is different than the previous problem because they've given you some roots for free, right? They've given you these roots here, and the goal is to find all of the roots all together. And so you would think that, okay, look, the degree is 7, so there are 7 roots, and they've given us 3, so that we have to find 4 more. But that's not true, and I'll tell you why. If you look right here, they're telling us that 2i is the root. And because 2i is a root, then you know what else is also going to be a root? Let me do it here in pink. Negative 2i is also going to be a root. Along those lines, you know how this says that square root of 3 is a root? Well, that implies that negative square root 3 is also a root. So here's what I'm saying. If you have a root that's given to you, let's say that, oh, they say that 5i is a root, 5i. Just think of the number 5i. If it is given that 5i is a root, then you know what also is going to be a root? Negative 5i. Okay? Let's suppose that they tell you, let's pretend that they say that, oh, the number negative square root of 11 is a root. Then do you know what else is also going to be a root? Positive square root of 11. These are called conjugates. And we discussed this in class, where if you have a number that is imaginary, then its conjugate is also going to be a root. If you have a number that is irrational, then its conjugate is also going to be a root. And if a number was complex, then its conjugate would also be a root. But not if it's something rational, like 1/5. You know how 1/5 is rational because you could express it as like a fraction between integers. Nuh-uh. If it's a number that's like a regular number or a number that's like a nice fraction, then do you include its conjugate? No, that's not what we're saying. We're saying if a number is imaginary or irrational, then yeah, for sure, you have to include its conjugate. So what I'm really telling you guys is for this problem, we have not been given 3 roots. We've been given 5 of them. 1, 2, 3, 4, 5 roots have been given to you for free. You just have to find the 2 other ones. Because the degree is 7, you owe them 7 roots. 5 have been given to you for free. So let's begin synthetic division here. So we know we're going to drop the 5. And we know that this is going to be our remainder over here on this side. But now the question is, which number do you want to use first? We have to use this one, this one, this one, this one, this one. All 5 of these roots have to go synthetic division, and then we can find the 2 missing roots, and then we'll be done. Which one of these do you want to use first? Again, it doesn't matter. Let me use the 1/5. So if I put 1/5 out there, and then let's run through this process where it becomes multiplication, addition all the way to the end. So let me just go through this as quickly as I can here. So this will be like this there. 0, 0, negative 180, negative 36 and 0. So that takes care of the 1/5. Now let me try next. Let me go with 2i. So let me drop the 5. And now we're going to go with 2i. And so when you multiply 5 with 2i, you're going to get 10i. Plus 0 doesn't change anything. It's just 10i. Now let me do some scratch work down here. How much is 2i times 10i? Well, the 2 times the 10, that gives you 20. But then I times I is I squared. And then remember that I squared is -1. So this is 20 times -1. And so that's -20, right? And that would go up here. That would give us -20. Let me take off the scratch work. And so this tells us that this is 0. And then multiplication, 0 times 2i is 0. 0, 0, -45. And then -45 times positive 2i is -90i. That's -90i. And in like fashion, 2i times -90i, you will discover that it's actually positive 180, which gives us a remainder of 0. Yeah, right? The 2i times the -2i, that'd be like -180i squared, but the I squared turns it into positive 180, remainder 0. Okay, so that takes care of this guy. How about next we throw in, if I'm going to throw in 2i, right immediately afterwards, I'm going to throw in the -2i. That's highly recommended. That if you throw in a number, that you throw in its conjugate like immediately afterwards. So let's see, multiplication, that's 0. If you add them, it just goes away. 0, 0, 0, 0, 0, -45. And that'll be positive 90i. And that's convenient because it gives you 0. So let me see if I can erase some of these earlier pieces. And let me see if I can take the current step and if I can sort of move it up higher above so we can all see. So let me see if I can just select all of this gibberish here. Let's see if I can move this up a little bit, leave it right there. Let me take off a couple of these things. So what have we did the -2i. Now, how about we use, let's go with square root of 3 now. Let's go with square root of 3. So this will be 5 square root 3 when you multiply. And if you add 0, it's just 5 square root 3. And now here's some scratch work. How much is 5 square root 3 times square root 3? That would be 5 times 3, which is 15. So I'm going to put 15 right there. And let me erase this scratch work. So I get 15 on a calculator, which is say 15 there. And this is 15. And this is 15 square root of 3 plus nothing. This remains itself. And then on a calculator, 15 square root 3 times square root 3, it would say 45. Because honestly, square root 3 is just 3 times 15 is 45. And that spits out a remainder of 0. And then, so let me check that off. And then finally, let's finish this problem by, let's throw in, now we have to throw in the negative square root 3. So let's throw in negative square root 3. Let me get some of this off the board here. Let's throw in negative square root 3 and let's see what we get. So let me copy all of this here and let's move this up, like right there. And let me continue with a different color. Let's go with green, Cal Poly green. Okay, and let's go with negative square root 3. Negative square root 3. So this is 5. 5, that'll be negative 5 square root 3, which is 0. And that's 15. And that's negative 15 square root 3. So that's 0. Let me just check that off there. So guys, we've thrown in all 5 roots. All 5 roots have been divided synthetically. All that's left for us to do is to build this equation and to find the 2 missing roots. And so we know that this is going to be x and that that's going to be x squared because that first number is your constant. And the equation that comes to life is 5x squared plus 0x plus 15 equals 0. The piece in the middle is 0, so it can pretty much be discarded. So we're left with 5x squared plus 15 equals 0. Subtract the 15 and divide by 5. That'll be negative 3. Square root, square root, square root. So we have plus or minus the square root of negative 3. But negative 3 can be separated as a negative 1. Square root of negative 1 and then square root 3. And so we get our 2 missing roots. So it turns out for this polynomial, we have 7 roots altogether. They gave us 3 roots, but really they gave us 5 because of the conjugates, how you always include conjugates of non-real or irrational roots. That was 5. And then we just found the 2 missing roots, positive I square root 3 and negative I square root 3. So of course you want to make a nice answer key that has all 7 roots together, which would of course include all of these guys here, along with these ones there. So I went through that quickly, of course, but if you have any questions, please let me know, and I will gladly respond.